Good evening, everyone. My name is Nimran, and today I'm very excited to share about my project, which is an Arduino-based radar system with an ultrasonic sensor. This project not only demonstrates the practical uses, but it also works as an extraordinary educational tool for learning more about sensor technologies and programming. So let's move forward. The major goal of my research is to create a simple yet effective radar system that calculates the distance to nearby object using an ultrasonic sensor. This sensor generates high frequency sound waves and measures distance using the time it takes for the echo to return. By connecting this sensor to an Arduino board, we can build a versatile system capable of real-time displacements. So now we'll move to project components. The setup will consist of an Arduino board, the ultrasonic sensor, a breadboard, jumper wires, and optional components such as LCD display and a servo motor for enhanced functionality. The Arduino IDE will be used for programming, allowing us to build and upload the code required to control the sensor and to process data. So now we'll discuss about the working principle of our project. Our radar system works on a simple principle. The ultrasonic sensor emits a pulse, detects the time it takes to return the echo, and calculates the distance to the nearest object. This distance then can be shown on a serial monitor or a connected LCD to provide us a real-time feedback. So as we can see on the screens, the jumper wires will help us to connect the different components. And for power supply, we'll need a USB cable or a battery pack that will connect our laptop or our computer to the Arduino so it can function. So resistors are also important in this project as it will guarantee the safety of our Arduino based radar system. So the mounting hardware will help us to maintain the structure integrity of our project. So talking more about our project, an Arduino based radar system uses an ultrasonic sensor and servo motor to detect objects and to determine their distance, direction and speed. So to build the system, we'll connect our ultrasonic sensor to the Arduino and then we'll connect our servo motor to the Arduino. So after that, we'll write a code. To write a code, we'll use Arduino ID and then upload it on the Arduino. So then afterwards, we'll use processing ID. Using processing ID to process the signal from sensor and display the output. So to test the system, we will connect our laptop to the Arduino so we can see the results on our laptop screens. So to conclude it, the radar system uses an ultrasonic sensor and that sends the ultrasonic waves in different directions. The waves bounces off the objects, reflect back to the sensor, which analyzes the characteristics of the waves. The Arduino then displays the distance and position of the object on the screen. So moving further, we can talk about applications now. The possible applications for this object can be numerous. It can be used for obstacle detection in robotics or parking. We use it in our daily lives, in our cars, assistance in automobiles and proximity detection in smart home systems. It also acts as an excellent instructional project for students to learn how hardware and software work together. So to conclude this, we can say that the Arduino-based radar project using an ultrasonic sensor provides a hands-on-hands way to learn about sensor technology, programming, and real-world applications. I hope that this initiative will not only improve my technical skills, but will also lead to new solutions in a variety of disciplines. Thank you so much. This was all about my project, and I will eagerly await for your feedbacks and inputs. Thank you.